We were just talking about the fact that, as many of you know, this is our 39th year of doing Science on Saturday after a 3-year break. And what I love seeing is that every week, the number of people in the audience is getting bigger and bigger and bigger. And that doesn't mean, I know we've got people on the Zoom behind us right now, so a big hello to you as well. But it's just such a thrill to be here every Saturday morning to talk about science, hear about science, question some of the things that we know, and learn where are things going in our world. And that's what today is about. So of course, welcome back, because I'll say this for the entire time that, maybe if that's a we missed you, but I certainly missed you. And it's so good to see everybody here. As always, just to go through some of the housekeeping, masks are completely optional. We monitor what's going on in the local health conditions. And as long as our local health conditions are good, you can choose to wear a mask or not to wear a mask when you're here. Please hold all questions till after the presentation, and then we'll pass out the microphones. And for those of you who are on Zoom, please make sure you're muted. If you use either the raise hand function or put your question into the chat, we'll monitor that and we'll try to make sure we get as many from that as we possibly can. So here are both today's and the next couple of ones that are coming up. So besides today on weather, we have next week on fusion, and in particular, someone from a private fusion company. Some of you may know that there is a significant amount of investment going on in private fusion right now to try to accelerate the path to a pilot plant. And then the final one in 2 weeks will be one where we're going to combine high fashion and fusion with a fashion designer inspired by tokamaks and by plasmas. And so that'll be the last one. But today, it is my distinct pleasure to welcome Dr. Lisa Thalheimer, who is here with us today, coming all the way from Europe. So when did you fly in?
I flew in yesterday and I arrived at probably like 3 p.m. and I crashed at 5.
So crashed
that
at
was
5. So wait, that means that right now, this is 9:30 in the morning. So it's afternoon. So you're fine.
Yeah,
All right.
I'm fine.
As you can see, she's at the United Nations University, the Institute for Environment and Human Security, which is really interesting. We were talking about that right before we started, a university at the United Nations. But her research seeks, I love this, to disentangle the underlying drivers of human immobility and attribute extreme weather-driven human mobility to human-induced climate change. I assume we're going to learn what that means, because I don't have the slightest idea right now.
I hope so.
She leads a project to understand climate change impact on mobility and conflict, has a PhD from the Environmental Change Institute at the University of Oxford and a master's from Columbia University. Would you please welcome Dr. Lisa Thalheimer? So I told her there's always 3 questions before we get started. So question number 1, when did you first get interested in science?
That is a wonderful question. Good morning, everyone, first of all. It's really great to be here and having a really fully loaded room. That's amazing. Biggest crowd so far. It's also great. To answer your question, it probably started super early when I think I was about 8 years old. Back in the 90s, that tells you a lot about my age. In 1998, there was a solar eclipse, at least in Europe, I hope here as well. And I built a 3D model with my dad to kind of scale the solar eclipse on a piece of paper. So what we did was we ran experiments of how we can best do that. And I should probably also mention my dad is an engineer, very typical for where I come from. Anyway, I'm German, so like most of the people are engineers for some reason, I don't know. Anyhow, so we did a lot of like tests from like really drawing out what we want to do and what we want to achieve to actually building a mock-up model to then, on the day of the solar eclipse, running our real-life experiment and really seeing, did that what we built actually work? And I'm happy to say it worked after a couple of, tricks and tweaks. It worked, but it was super exciting for me. I mean, I was super young. I had no idea what it means to be in science, nor did I know that I want to be in science one day. At some point, I wanted to become an astrophysicist, but that's different today, I would say. Yeah, but it's been like super early on, and I would say my mom and my dad have both inspired me to go the science path forward, or to take it forward.
So when I ask who is the most influential teacher or one of the most influential teachers, I don't know if that's your mom or dad, if there was someone from school, but at any point from being a young child up through your PhD.
Also, a really interesting question. I would probably say my teacher in middle school, my English teacher. So when I learned English, which was my first foreign language, we had to pronounce the TH because that's not something very typical in my language. So it was super difficult. And I remember my English teacher made us pronounce London because it sounds very similar to when you land a plane, at least in German. So this was one of the most memorable points in my life, I would say, because I was really eager to thrive, to pronounce English in a hopefully good way, but also to use English and think in a different language. And I think this really inspired me.
What language did you dream in?
Ooh,
I made that question up. Everyone knows that.
it's probably English because I work in English. Most of my colleagues are international, and the common denominator is English. So probably actually English. Yeah, I have a couple of weird dreams lately, but English. Yes.
I'm not going to ask you to share. Last question. A hobby or something that's not work, not science related, that is something you enjoy doing.
I think I like solving puzzles. So from Scrabble, I love playing Scrabble in English. I even have a mug with the two-letter words. That's me. But also, I think escape rooms is something I really enjoy. So solving puzzles, quote unquote, together with other people, I really enjoy that.
That's wonderful. So why don't we have you share your screen? And then I think we are good to go. There we go. What is up with the weather, Dr. Lisa Thalheimer? The stage is yours. Thank you.
Thank you. So again, thank you for making it all the way here. I know it's early. I know there were bagels outside. I definitely arrived too late to grab some bagels, but never mind. I had a couple of waffles, so that was also nice. I am Lisa Thalheimer. I'm a hybrid between a climate scientist and an economist. Did economics in my undergraduate and master's degree and switched to climate science after some memorable moments at the World Bank, where I worked for a couple of years before deciding to go to academia. Today's talk is really inspired about my work, but also when I was asked to give this presentation, this talk, I wanted to have a topic which many of you can hopefully identify with. After having lived in the UK for a bit, the weather was always something up. Everyone asked like, oh, it's so hot today. Why is that? Or it's super cold. Why is that? So all these questions really inspired me to give more like a public talk about my research and what's up with the weather. I hope we can answer this question. There we go. Great. Technology is with us today. A small outline of my talk today, and feel free to ask questions later. I'm really excited about your questions, from smaller ones to bigger children. I think everyone's hopefully interested in weather. First, I would like to talk about extreme weather, so floods, droughts, and all of that. Why should this matter? Why does it matter today? And then also looking at impacts and what I call human responses to extreme weather. So for instance, do people go because of extreme weather events? What's happening in terms of conflict? So all these also a bit media-inspired questions. I'll conclude with a couple of takeaways, especially from my research, from things I've personally learned, but also from ways we can maybe think about extreme weather and the impacts from climate change. I wanted to start with a lens on the US. You see here two pictures. On the left-hand side, we see the Calder fire in California from 2021. It had a huge impact on populations. A lot of houses were destroyed. It costs lives, so really detrimental impacts. On the right-hand side, we see Hurricane Harvey. We see that in Texas, there were a lot of floods caused by Hurricane Harvey. A lot of houses again damaged, people being displaced, huge impacts also on the economy. I wanted to show these two pictures really to define extreme weather, that we're not talking about something like, oh, there's a bit more rain here, or it's a bit warmer here. No, really about the extremes, essentially. My research is very much about the climate change fingerprint, because not in all extreme weather events we can actually see a climate change fingerprint or impact. And I think that's super interesting. Andrew, when he introduced me, used the word disentangle, and this goes back to what I do, really teasing out when climate change plays a role and when it's essentially just natural variability. And this has important implications for when we think of reconstructing from extreme weather. Does my insurance pay for that? Yes or no? Can I claim certain things from my insurance? I think these are all questions which should, at least all of us at some point, interest us. Again, I thought it's probably nice to put this also in numbers. I mean, extreme weather has been impacting the US, essentially almost every state. What we saw in the 1980s was that about $29 billion events hit the US. But what's really interesting is that the damage was round about $180 billion. When you look at the numbers just between 2010 and 2019, it's a different picture, definitely. So we see $44 billion events with responsible damages for almost 500 billions. And that is an average of almost 12 events or 81 billion a year. That is massive on the economy. But then again, we don't really know. Is climate change to blame for that? What can we essentially do about all that? Part of my research looks at what's called climate change attribution. Looking at, okay, we have an extreme weather event, and what is the fingerprint of anthropogenic or human-induced climate change? We ran with a group called World Weather Attribution, various different extreme event studies. One of these studies is, for instance, the Western North American heat wave from 2021. Maybe you remember that from the news. Usually it's highlighted first by the news. Canada experienced record heat of, I think it was 49.6 degrees Celsius, which is massive. I mean, I'm not sure how to survive in such heat, nor will you probably know. And so this kind of trigger motivated us to do a study really asking, does climate change play a role in this heat wave? And we found that it actually played a massive role. Without this, the climate change that is happening, we would have not seen such a heat wave of such detrimental impact. What we should also notice is that heat really impacts not only humans in a way that we could die, but also thinking of people who work outside, from gardeners to those who build roads. They are not essentially able to perform their work anymore if it's 50 degrees Celsius outside. In Fahrenheit, that is definitely over 100. But what I also wanted to mention is that not only the US is obviously impacted by extreme weather. We run various different event attribution studies. This is kind of the big term that's called. And it's not always climate change that plays a role or that is the driving cause of extreme weather. Sometimes we can say, yeah, climate change has caused that, this kind of abstract construct, right? But sometimes it's other factors. In a study on Madagascar, we looked at food security and insecurity, essentially. And what we found was, looking at the drought in the very, very south of the country, was that climate change had nothing to do with the drought. It was various different types of vulnerability, especially poor infrastructure and not nicely set up government that never renewed the infrastructure, people being trapped, people not being able to move when they wanted to move away. And these were various different compounding factors, all that are interlinked and played a massive role. But in this case, climate change was actually not to blame. And I chose these two examples specifically to highlight that it's not always climate change we can blame, but it's other drivers as well. But then again, you might ask, so what can we learn from this? What should we do? So the Intergovernmental Panel on Climate Change, or short IPCC, that's basically a lot of scientists coming together and reviewing a lot of different scientific papers. They came to the conclusion that, and you see it in the title, climate change is already affecting every single region across the globe. Very big impact, with human influence contributing to many observed climate changes in weather and climate-related extremes. This is huge, that a lot of scientists come together and say, yes, climate change has a fingerprint in all and many extreme weather events happening across the globe. I think this is pretty massive, especially when we consider that not all the, for instance, weather stations are distributed in the same manner across the globe. Sometimes we actually don't have the data to specifically say, yes, climate change played a role or not. And I think this is in this term also interesting that we have a differentiation between various different extreme weather events, and the IPCC really backing up, yes, climate change is something we should look into, and this is something we should further investigate. And similarly, we have also human influence in a lot of gases, especially greenhouse gases, and they're most likely the driver of the intensification of a lot of extreme events, especially heavy precipitations. So think of floods that are occurring. You've probably seen the cyclone Gabriella in the news that is occurring across New Zealand, and we're currently investigating also whether climate change has any role to play in cyclone Gabriella. What's also interesting and worthwhile to notice is that these are global trends, obviously, right? But extreme weather is happening on a very local scale. It's never the whole US which is impacted by an extreme weather, but it's various different states or communities. And really zooming in that global trends are not essentially the same as local changes is something I definitely wanted to highlight from this image. What's really nice is that a group called Carbon Brief is actually mapping where we have attribution studies, so those studies who link extreme weather to climate change, and where we see an impact from climate change, and where climate change actually does not play a big role. What you see here are all the various different types of extreme weather events. So for instance, the drop in blue is something where they did not find a huge climate change signal in the data. But then in red, overly, what you see here is that climate change actually played a role. So I think, yeah, the lightning sign, that is probably a cyclone. The drop is a flood, and the temperature thing is heat extreme. So that's really interesting that this is all in one map. And what I also think is important to know and important to mention is that there are effects from extreme weather that are not only on the economy, but also on populations. In the rest of my talk, I'll go especially into detail of non-economic losses, so those impacts on populations especially vulnerable to climate change. Yeah, but let's stay with the economic costs for a bit longer before we dive into a country case study. So the costs of extreme weather are actually likely to rise, but also those costs associated directly to human-induced climate change are currently most likely undervalued. What we see from one study on Hurricane Harvey is that around 67 billion of the damages that are in total 90 billion can actually be associated or attributed to climate change. That's really interesting. This is more than half of the damages. And when we just look at a kind of like traditional economic model, we don't get as far with our calculation. So this also highlights a bit that we need kind of new models, but also more climate science to better understand the economic impacts. And I picked here the example from a very famous economist called Nordhaus. The Nordhaus model, running the same kind of numbers, came to the conclusion that climate change is only to blame for about 20 billion. I mean, 20 versus 67, that's a very big difference, especially when you go to an insurance company and essentially say, hey, so our 20 billion should have been insured, but not the 67. So what happens with the difference? At the end of the day, it's a lot of people who can't reconstruct their houses, who can't move back. So you see kind of the long-term implications when these numbers are not sufficiently addressed. And this is probably the most boring slide I have. I apologize for that. But I wanted to stick a bit longer to the numbers of economic losses from extreme weather. So there are different numbers and different number providers. And what I wanted to mention here with this slide is that there are different people who report due to their models, different numbers, of course. So the insurance company Munich Re, for instance, said that, okay, there are 210 billion US dollars that extreme weather events caused. What's also interesting is that a lot of these impacts and a lot of these costs are also in low-income countries. Low-income countries who cannot afford these extreme weather events, who cannot rebuild or reconstruct. It has a much bigger impact on communities. Imagine you are hit or your house is hit by a cyclone, but essentially every money pot is missing to reconstruct your house. Where should you live, right? And so a lot of people in especially low-income countries are faced with that question. By 2030, which is not too far in the future, it's expected that over 300 billion US dollars are actually needed to adapt to climate change. Adapting to climate change could be building better houses. It could be to also do planned relocation as a last resort. I'm not advertising that, just as a last resort. This is a very political topic, but essentially having measures in place to be prepared for extreme weather, to be prepared for another drought, for another flood or heat wave. And what we also see from the data is that the costs associated with extreme weather, not looking at climate change, but just from extreme weather, are actually rising. I think this is really extraordinary, but also this chart tells you, yeah, it's rising, but it doesn't actually tell you where it is rising. That's what I find really interesting, because again, in low-income countries, we don't have data that can be nicely plotted like here. And this really inspired me to also look at non-economic losses. Those losses which can't be only put into numbers, but that are still huge, right? Because if people get displaced, if there is war essentially from climate change, just hypothetical, it's something we probably can't put numbers to so easily. What I wanted to highlight here from this slide is that the media picks up on the impacts from extreme weather and usually associates that with climate change somehow, doing like a direct causal link. For instance, climate change caused food insecurity, or climate change caused war. I think this is very interesting because most often this is not scientifically proven, and it's one of the motivations why I do my research, why I tend to look at and disentangle, the word underused, these various different effects and impacts from extreme weather and seeing what does actually play a role. Why do people, for instance, become displaced? Is it just extreme weather? Do people actually move because they have better economic opportunities? We don't know. For the rest of the talk, I'm zooming away from the US and into a region which I personally find very interesting, East Africa, especially Somalia. Somalia is located in East Africa, so at the Horn of Africa, and you can see it kind of shaped as a 7. It has very few functioning weather stations, so it makes it a very interesting place for climate science, before I put on my economist hat again. And we have a lot of problems in Somalia, not only from the weather side of things, because we have a lot of recurring floods, recurring heat waves, and drought as well. Currently, there's a drought or drought conditions going on since 2015. And for a country that is largely running on pastoralism, so herders going with livestock from A to B, that is super difficult. It's super difficult to find water, to find food, but also to make a living, essentially. In 2010, 2011, we already had a drought that led to famine conditions, and that made definitely the news in the past. And currently, there are also a lot of food insecurity conditions, but at the same time, we don't really have proof that climate change plays a role. Had we had that proof, we could probably allocate funding to prepare people for the next drought, to build better roads, for instance, to deliver humanitarian aid. But without this proof and this evidence, it's quite difficult to help the population on the ground. And this inspired me to look also what's available in literature. What do we actually know about the country? And are there any avenues or pathways we can kind of carve out and see if climate change plays a role? A first attempt was made in 2017 by the group World Weather Attribution. That was definitely before I joined, because that's just when I started my PhD. And they did an attribution study on the drought in 2016 and 2017. So just 5-6 years after this drought-induced famine, another drought hit the country. And the population was basically not able to recover, to reconstruct, to rebuild. And a lot of people were made way poorer and left in a limbo of not knowing what to do, because many extreme weather events were affecting them again. Unfortunately, the study did not find a climate change signal. Why is that? First of all, it is extremely difficult to define when a drought starts and when a drought ends. The group did one thing, that they looked at overall extreme weather conditions, in this case, lack of rainfall, between January and December 2016. This is what you can see on the right plot. What you can also see is that the kind of orange colors are less rainfall than usual. So you already see, okay, the country had less rainfall than usual, but it's not as severe. If you look at the left-hand image, you see, well, there's really a lot of rainfall deficit going on, also across the whole country. I think this is super interesting in terms of like better understanding when a drought starts and when a drought ends. We can't really say, okay, the drought ended, but we can definitely say the drought was in 2016 extreme during the time of September and December 2016. But again, this going back to my question of the non-economic losses. We still don't know the answer, essentially. What I've learned from working on Somalia is that there are loads and loads of things going on. There are a lot of risks, there are a lot of vulnerabilities, but essentially, to sum it up, there's conflict, there's poverty, there's a lot of displacement, there's a locust crisis, which destroys crops, which affects livestock as well, so people basically cannot do their job anymore. And we have loads and loads of food insecurity, as well as obviously the coronavirus pandemic is also affecting the country quite a bit. In 2021, we had 3 million internally displaced people, or IDPs. This is about a fourth of the whole population. So just imagine a fourth of the people in the US were forced to move within the US. That would have been an outrageous number, right? And you wouldn't want that probably, because most people could not be with their families. Most people could not do their daily jobs or, enjoy their free time. So what we did in a study recently was asking okay, if there's so much going on in Somalia, when is it actually weather and when is it conflict that affects people, especially having to flee within the country? It's super interesting what the UN does. So the entity of the UN which is responsible for tracking and monitoring refugee movements is called UNHCR. UNHCR has a unique data set which basically records monthly and weekly, so weekly and monthly, I should say, displacement across Somalia in districts, so very, very fine regions on the map, 74 districts, but also across a, I would say, fairly big time frame of 2016 to up to now. And what we did with this data set is, first of all, looking, okay, when does drought play a role and when does conflict play a role? And there are three things I would like to highlight from this. First of all, what you see here is displacement flows. So those people who have been displaced had to flee essentially within regions or also across regions. The blue arrow on the bottom here shows the area of Bay. You don't need to know where Bay is, but what's interesting is that within Bay, a lot of people move. That means, okay, it's really short distances where people go, but they know they have to flee. And the other thing I wanted to highlight is that both in drought displacement and also conflict displacement, we have this region of Banadir and Lower Shabelle, where people go to and are forced to flee, essentially. I think this is another really interesting kind of coincidence that due to both reasons, people are fleeing, but very short distances again. It just happens that Banadir and Lower Shabelle are next to each other. But again, this doesn't leave us really with answering the question, when does weather and when does conflict play a role? What I also wanted to highlight is that generally it's not super easy to have an answer to this question, because there are a lot of data issues when it comes to migration, displacement, or refugee data. Most of the data is recorded and also maintained by UN entities. And the way they collect data is usually quite different from country to country. So it makes it very hard to compare countries, for instance. It makes it really hard to associate that to extreme weather or conflict as well. This data set we're using for this study is from UNHCR, and it's quite unique because it records the reason of why people have become displaced. It's available for a really long time frame. So again, you might wonder, like 2016 to now, that's not a long time frame. But in terms of migration and displacement data, that actually is. Having that without any interruption is quite unique and makes, in this case, work much nicer and easier. I looked at the latest numbers of displacement this morning, and just this year, actually they didn't update it since January, but there were 288 new displacements. New displacement means people being displaced because of one of the 4 reasons: drought, flood, conflict, or other. Other are secondary reasons they just map together, apparently not important enough. But I think it's really interesting that UNHCR goes to a country that is so impacted by both floods or extreme weather and drought, but also by conflict. I mean, it's pretty hard to be able to interview people on the ground if there's essentially a fight scene right behind you. So I have a lot of respect also for UNHCR going to this country and asking people why they've become displaced. So to come a bit closer to the solution, we thought, okay, why don't we actually look at various different, what we call pathways of how extreme weather, in this case drought, affects both conflict, but also displacement. What you see here is, it's probably also not the most super duper fancy picture, but it shows you kind of how we thought about the process of why people become displaced and where they go to and why. So extreme weather could have an impact on drought displacement. Those people who actually say, yes, we've become displaced because of drought. Or those people who say, okay, we've become displaced due to conflict. So we're testing first the extreme weather effects on displacement due to drought, but then also looking at conflict, the effects of conflict on displacement, especially because the media very often said that those people who migrate from A to B might bring conflict with them. So we're also testing this fairly, I would say, political issue. And then we're also looking at the impacts from extreme weather on the likelihood of conflict occurring within Somalia. And some of the key results, you see a lot of people. These people are meant to be those displaced, the IDPs. What we find is quite extraordinary, I think, at least using this data set. So we find that a 1 degree Celsius increase, which you think like, oh, that's a really small number, right? That's not a lot, can actually cause a tenfold of displacement. Just a marginal increase in temperature has such a big impact. If we're looking at the future and future impacts from climate change, especially with the 1.5 degree Celsius goal in mind, which is probably not feasible, these numbers are likely to increase in the future, having more creating more displacement within the country in the future. If we look at essentially no rainfall in the country, or rainfall really dropping from, for instance, 100 millimeters to 50, we also see that these numbers we have had before are actually doubling. And going back to the story of Somalia, where we have a lot of droughts and also floods going on, this really doesn't prepare people to be able to reconstruct and to develop in a sustainable manner. And then last, we also looked at the effects from extreme weather on conflict, but then also displacement on conflict outcomes. And what's really interesting is that in all the data, and we looked at all the years, there's actually no point where those people being displaced, having to flee from A to B, bring conflict with them. It's much more likely that people cooperate, that people take those people who flee in and share resources. And this really goes against what's been very often reported in the media, that people bring conflict with them. But what we really see is that people are much more likely to cooperate and share the, essentially scarce resources they have. And this kind of dispels this common myth, at least for Somalia, I should stay in the country of Somalia, that displacement might fuel conflicts. And I think this is, at least for a country that is experiencing a lot of conflict and a lot of extreme weather, an interesting result, especially when it comes to humanitarian aid and how to drive solutions forward to help people on the ground. But as always, there are limitations to every study. So I talked a lot about conflict and the likelihood of conflict occurring, but we also have a couple of limitations when it comes to conflict. So one is spillover effects. So what essentially happens when neighboring regions also experience conflict at the same time, but then, we might attribute the IDPs, the internally displaced people, wrongfully to move into another region. That could definitely happen. And another thing is also reverse causality. We could have IDPs moving to low conflict regions. We should mention these limitations. We actually don't see from the data that this is, or we can't prove, I should say, we can't prove from the data that this is actually occurring, but just, as a caution that we have data, but there are limitations. From the study, we were also interested in having real world solutions and also recommending things, for instance, humanitarian agencies or development agencies could do. One thing, of course, is to support humanitarian operations, right? Especially the delivery of food, the construction of roads to deliver the food, but also helping people in terms of agriculture to have climate resilient crops, but they have to be delivered somehow. We also highlight that there's a necessity for early or anticipatory action. What does this mean? So for instance, we know that we have a couple of weather forecasts So how can we use the weather forecasts? We can essentially pinpoint the location of an extreme that is likely to occur and then prepare populations before the extreme hits them. That could be, for instance, having evacuations just for a period of time before the disaster hits, and then after the disaster, they can essentially go back to their houses, or improvements in roofs and houses, but also delivering food and other types of humanitarian aid, such as water, for instance. And I think I wanted to conclude with why we're looking at Somalia and why this should be relevant for you guys in the room, because obviously the country is very far away. So why would you care? I think in a just world, we're all responsible for the actions, what's happening with climate change, but also to do something about it. I very often get the question, I as a single person, how can I help? How can I mitigate? What can I essentially do so that climate change does not, take the world over? And I think it's really important to work together and work together jointly on something, and not like the image shows you that essentially the disasters are collaborating better than we are. But having joint solutions, hopefully also cross-country, would be something, preferable. And with that, I'd like to conclude.
Hello?
All right, so you're good there, right? I can take a look
Mhm.
and we'll go there. Are we ready? We got one mic there and I think we have other mics coming. So 1 second, I know some people are headed out. All right. Go ahead, question's yours.
Well, thank you for the presentation, first of all. It's very interesting and enlightening. I had a question on the slide where you were showing basically a map and it was different hexagons. There were certain zones that I think said like confidence in climate change is low due to limited agreement. What essentially does that mean? Because I noticed, I think Eastern North America, which I assume we're in, was one of those zones. So I was very curious about that.
That's an excellent question. So this goes back to the literature we have available. Sometimes studies find, oh yes, climate change plays a role in an extreme weather event, and sometimes another study using essentially similar data, using similar time frame, finds, okay, for that event, no, there's actually no fingerprint of climate change. So this kind of, the IPCC is really adjusting that. We have studies that say, yes, climate change plays a role, but also, no, there is not. And so they have these confidence intervals, and a confidence interval is obviously then lower if studies have kind of contradicting results.
We have a question right up in the front. Sir. From our director.
Oh,
Thank you for a wonderful talk. That was tremendous. Are there going to be delayed effects from some of these things in the sense that in mitigating the issue, you do things like you drill more wells, you deplete aquifers longer, so that actually what we're seeing now is going to get worse because our ability to mitigate becomes less and less with time?
that is a very relevant question. So the actions we do today have an effect in the future, definitely. I think one thing that is really important is the frequency and intensity of extreme weather events that come in between. So if, for instance, you outlined the example of drilling wells, if we're not able to mitigate the impact from extreme weather events, also this will have a huge impact on drilling wells, in the sense that it's made, essentially that solution is made worth nothing, right? I think one of the important key factors is really to come up with climate sensitive solutions. They're also community sensitive, so really looking at community knowledge and really looking at how we build and how we drill the wells and where. That kind of requires community knowledge, but also engineering knowledge, and having that combined will be an ideal solution. This is something I would like to see, but it's not happening everywhere.
We're going to swing it around to the other side of the auditorium, right here.
Okay, thank you. In 2012, the IPCC released the SREX report, the Special Report on Climate Extremes. which basically argued that it's really difficult to attribute any kind of extremes to climate change. Additionally, there's 1 degree of centigrade of climate change, and the boost to 3 degrees centigrade is due to water vapor feedback. So I was surprised that most of your talk centered on droughts. Is there really definitive evidence that droughts are increasing? Because under the normal arguments of climate change, one would expect that floods would be increasing, not droughts.
That's also a very interesting question. Thank you for that. So you mentioned the IPCC report from 2012. That's 13 years ago. There have been new reports released since then, and the literature essentially and studies on attribution have been growing, and the methods have been refined essentially during that time. What I wanted to highlight is not that droughts increase, but the frequency and intensity of droughts are increasing. So it doesn't mean that the whole world is experiencing droughts, but the droughts are hitting those countries which are kind of normally affected by droughts in a much more severe way. And we're not prepared, or populations are not prepared to deal with that. And then if floods are happening in a consecutive manner, the soil is essentially so dry, it cannot absorb the additional water from floods. So heavy precipitation is very likely then to turn into floods because the soil is not able to take that additional water. Does that answer your question? In part, you can ask a follow-up question, because I think the most important thing is that science has advanced since 2012, and also the methods of how we attribute climate events.
I don't see any evidence of the ability to attribute extreme weather to climate change at all.
I think this is something you have to take with the IPCC then, because the latest reports do show that. So this is not something I can defend.
The 1 to 3 is water vapor feedback, so you should get more moisture, not less.
It's different across the globe. It's not.
So we're going to go up into the back corner, Gary.
Discuss climate consciousness. Can you hear me?
Yeah, a little closer.
Climate consciousness, if you would. This is not an interrogation, but an observation. There used to be a comedian called George Carlin, who part of his stand-up comedic presentation, he'd do the weather, and it was very brief and to the point. He'd say, dark tonight and light tomorrow. Now, working on that, bit of attempted humor, do you think the way the weather and or climate is presented to the American public nowadays is really very informative? Or as I say to my wife, when we watch the weather, it's a little more than a fashion show.
I like your question a lot. Also because it shows a bit. I've watched the news in the US, but I wouldn't feel like entirely confident to rate the news in the US, because they're like set in a very different way. I think what would be nice is if weather would also be presented in a way how it impacts people, but also more the scientific evidence. So there's a public TV station in Germany called ARD, and at 8 p.m. every day, they're highlighting the science evidence behind extreme events, behind climate variability, what this essentially means in terms of the climate change fingerprint, but also highlighting evidence from the IPCC, just to have more engagement, more scientific engagement with the public. But it also took about probably 15 to 20 years to be able to broadcast something like that. So it would be nice if the US could move in a similar direction, but I'm not sure if there's appetite for that. I would hope with the new generation and those people who are concerned about climate change impacts, there is. But I think then it's also the responsibility of people to bring that up to local politicians, to the governor, and so on and so forth. So really speak up if you're interested in hearing that and seeing that on the news.
There's a question right there in the back.
So my question is, people are displacing in this country voluntarily, and they seem to be going towards like Phoenix, Arizona, Texas, Florida, places that we know are going to get hotter and worse in weather. And is there anything at the UN, US, or any other level, kind of pushing people to go places that are not going to get hit by weather issues?
Interesting question. I think voluntary displacement, you probably mean people who might retire and, might retire in a nice state of Florida and enjoying the sun because apparently they haven't gotten enough sun throughout their life. Yeah. This is a different issue because it shows basically that people have the money to go from A to B. They migrate. It's not necessarily displacement, even though I absolutely know what you mean. It is very difficult to tell those people, oh, you have this nice house with an ocean view and you have 6 beaches around you. Amazing, great. And you just bought that for $1.5 million. What a bargain. This is great, but I don't think people are necessarily aware of the long-term effects it has on their real estate, nor do people care, because if they're actually retiring, probably the next 20 years are not as relevant as if they were in their 20s, to say it very diplomatically. Yeah, but it is an issue. It is also an issue in terms of those people who live in poverty, for instance, in Miami. Those people who live on higher up grounds, they get displaced because real estate is becoming so expensive, they can't live there anymore. But those people with more income are actually moving higher up, so they don't get impacted by sea level rise and other impacts. It's a relevant question. Yeah.
There's a question in the back, and then we'll do a couple from the Zoom.
Hello, thank you for coming to speak with us. We see obviously more IDPs in displaced countries because of the inherent vulnerabilities. But in more developed countries like the US, where we have, say, backups like insurance systems, as we see more of these disasters and the insurance systems can't cover those disasters, do we anticipate a much higher level of IDPs in the US?
That's also a very interesting question. I don't think there's a yes and no answer because similarly to the gentleman in the front row asking about the intermittent effects of extreme weather or actions we do, I think there are intervention points where we can help that, the displacement risk is minimized and people don't have to flee, don't have to leave their friends, their homes. But I think it will be necessary to work with the insurance companies together. If they can't cope anymore and can't pay, I mean, it's not in their interest essentially, because ultimately they'll go bankrupt, right? So highlighting again this concept of early action, if it's possible to forecast an event and move people preemptively to then, move them back, at least you don't have lives lost. If there were subsidies, for instance, like in the UK, there's all this like retrofitting homes subsidy going on. I think that's something one could look into. So there are definitely certain points you can tease out and minimize the displacement risk per se on the long run.
I'm going to just do one question from the Zoom. There's a whole bunch. We'll try to get as many as we can, and there's more in the audience. Great presentation. Thank you. Would you talk about reversible and irreversible effects of climate change? And would these arguments help to pursue or persuade policymakers, not exactly like doomsday scenarios?
Thank you, whoever asked this question. I do tend to use the word doomsday scenario very often because this is not something I hopefully portrayed. There are definitely intervention points, and there are definitely irreversible risks or impacts from climate change, such as habitat loss, such as especially on the ecosystem. And when we look at extremely vulnerable populations, also on islands, they're losing essentially their ability to further live on particular islands, such as Vanuatu, for instance. I think it's hard for me to pinpoint an exact number of irreversible climate change effects. But again, what I would like to highlight is that we all have the ability to pursue climate action, if it's on a political level, on the personal level, on the how you invest in stocks. All of these factors play a role in order to avoid having irreversible not irreversible effects from climate change.
There was a question straight in the back.
Hello. So I was wondering if you think that giving information about the causes of extreme weather events and, you know, how to deal with them effectively to the people in the low income countries who are impacted by the climate events, would that be helpful to them, or do you think that it would not make much of a difference?
I think in general, a storyline approach is super helpful. So not just to highlight numbers, but actually to have a mix of a bottom-up approach, really including communities and hearing about their experiences, and then having this hopefully trickle up to the more higher up level, like political level, and those who can actually change something in terms of laws and in terms of the government structure. And I think it's a little bit of a dance between both of them. Like one has to listen to the other, and one has to also be able to do compromises. And I think this is something I would see as way forward. And this counts for both low-income countries, but also more richer countries, essentially.
And I have a bit of a follow-up question. Do you think the spread of misinformation about climate can hurt these people? And if so, as you mentioned, the trickle effect, does that get to higher up people as well?
Yeah, I think misinformation is definitely especially dangerous if we underestimate, but also if we overestimate something. So if, for instance, we overestimate effects from climate change in terms of like US dollars, and it's not as costly in the end, people will think twice the next time they help a certain community. So what I think is super important, and this is what I tend to do in my research, is having a range of different scenarios. So for instance, we don't always have one number of displaced people, but it's usually a range of a number of displaced people between, let's say, 12 and 15 or so, to make it really tangible. But I think it's important to also listen to the science and different types of science, not always to have like your one go-to study, but also to read as diverse as possible.
There's another question over there. Yep, you should be on.
So, okay, yes. I know you referred to locusts in Somalia, and I'm just curious if your research or your colleagues' research also looked at this increase in invasive species, both flora and fauna, and their effect on just the farming and food supply chain, and how that's leading to all this migration.
Yeah, that's a super interesting question. So I think I'll zoom out a bit from Somalia. One of the things which is definitely impacting from climate change is the distribution of invasive species. For instance, if we don't have as cold winters, likely those invasive species are likely to live longer and not die in the winter, for instance. So again, this makes the crops more vulnerable to essentially risks from these invasive species. One of the impacts of that is essentially we have less crop yields, so less crops we can harvest, which are healthy, so to say. And then this has trickle effects on the food system in general, like the process of wheat, for instance, for, I don't know, flour or so, it gets impacted and flour prices increase then. This is essentially what's happening in Somalia, that prices really skyrocket between a certain extreme event and another extreme event. This has little to do with war. It has actually something with food availability and also the availability of humanitarian aid. So having kind of these interacting factors of both the price of food with the availability of food is something really dangerous in terms of climate change impacts.
So I think we have two questions from students. I was not sure, but one is, right, you're going first, and maybe there's someone going second.
So if you see this continuing, climate change and us losing this mass amount of money, trillions and billions of dollars going into helping these people regain their houses, do you see the economy ever coming back to what it used to be?
Wow, this is a big question. Thank you for asking this. This is a really important question because it gives us the umbrella impact of climate change. I think it's very hard to make a prediction of just looking at climate change and the impacts of the economy. There's so many other factors, like for instance, the COVID-19 pandemic, which had huge impacts. We're talking about systemic risks, so a system and like another outside system impacting our economy system. So things we cannot really control are happening as well, which then impact the economy. I would say it's never only climate change, but we have some control over what we do in order to maintain the economy, in order to bring it back to sustainable levels, I would say.
And then, go ahead, right next to her.
I was wondering if you think in the future climate change is going to affect more or less populated areas around the globe.
So research actually shows it's impacting the more populated areas. That is because of a number of reasons. One is diseases could spread easier in more densely populated areas, but also if you look at the transportation of, for instance, drinking water, if that is contaminated, again, we have a huge amount of people who are directly impacted by polluted water. In terms of more the climate or extreme weather events, we already see urban heat waves. So kind of cities have their own mini climate, and this is much more likely to be accelerated because of more densely populated areas and also because of the further increases and frequencies of extreme weather. So definitely say that urban areas are at more risk and danger of experiencing more severe impacts.
There's a couple questions about modeling from Zoom. I'm going to combine them into one. And it just has to do with how things might or might not be considered. So one was population, and in particular, future population, whether it's in Somalia or anywhere else. Is that a factor? And then another one was from the economics. The economic impact of an extreme weather event is much easier to quantify than climate change overall, so which is a slow economic change. Is that considered in any of your models? So those two are coming from the Zoom.
So I take the first one first. So the population kind of variable within climate data is definitely there. You can kind of account for population using population models that are out there. I think they're provided by NASA and Columbia's Season. Don't ask me what that stands for, but essentially you can account for population and also for future population models. This is especially interesting if you do kind of forecasting or recasting of extreme weather events. And the second question?
Second was, does the model consider the fact that it's easier to quantify an extreme weather event, economic impact, but climate change, heat islands, are not as easy when it comes to what's the economic impact? Are those considered at all?
In classic attribution studies, those impacts are not included. Then we're talking about impact attribution studies. So impacts, for instance, on the economy. But essentially, it's another stretch looking at the actual economic damages and then doing a reverse calculation of how that might have looked like had the extreme weather event not occurred.
Thank you. A couple more questions. One in the back.
Hi, thanks for the really interesting presentation. You presented a model of the causality connections between climate change and drought and displacement. And you also mentioned challenges with data, very limited data and data with different quality and variance and such. I'm curious, generally, how are these models validated given these challenges and given the sparsity of data?
That is a super interesting question. So first of all, not all data is created equally, especially in countries where we don't have, nice weather services, like in more wealthy countries like the US, for instance. Another factor is also how the data is maintained. So data collection can be one process, but then again, someone else comes in and says, oh, we should do this differently. We should collect data differently, but then it doesn't become comparable. So that can also contribute to data scarcity within lower income regions. In terms of the research I do on East Africa, I have to live with that limited amount of data that is out there. what I'm really excited about is, fast forward, is that we're currently doing an attribution study on East African droughts. And droughts are super difficult to attribute because, again, we don't really know when a drought starts and when it ends. What we can do to mitigate not having that great quality of data is using satellites. So there are a couple of satellite derived data products, especially validated for the East African region, that are really working well. They've been validated using on-the-ground stations, especially in Kenya and Ethiopia, where we have longer range of weather stations. In Somalia, that's much more tricky because they tend to get destroyed very often, and they wouldn't be as reliable for a validation process.
And I think our last question is right here.
So I know you spent some time at the policy school at Princeton, so I wanted to push you a little bit on policy, which is, in terms of Somalia, what do you see as a policy intervention that could work there? And then secondly, in terms of building a just world, as your last slide suggests, what do nations need to do to work together to mitigate climate change?
Wow.
No pressure.
Yeah, I don't know, of course. So policy interventions are a couple of them. One thing is definitely highlighting the early interventions. So we have absolutely amazing forecasters of droughts and floods and also heat waves in Kenya sitting. But what do we actually do with these forecasts? Well, right now, there's not much. I mean, a couple of early actions are now piloted, and they're trying to help people on the ground. But really, this study can help, especially pinpointing the locations of where people are likely to get displaced due to both conflict and drought, and what we can essentially do in terms of early actions before another drought, before another conflict is likely to hit. Obviously, predicting conflict is much more difficult, but let's leave it this way. And then your second question, could you quickly repeat that? Oh, okay. Nations needing to work together. One, definitely having an understanding that the impacts from extreme weather are not happening in your neighbor's backyard, but it's happening everywhere, and we're all affected by that. That is one thing. But also speaking a common language, having science as the kind of translator of these impacts and really working together in terms of using scientific evidence and bringing it to the next level. I think this is something I would hope to see much more and more in the climate negotiations, but also, I mean, I see it at the UN at the moment, that they're much more picky about which science to look at, but also using different types of studies, you know, not just like the study which is convenient to use, but also looking at different types of evidence.
And with that, if you could join me in thanking once again, Dr. Thalheimer.